In the relation x is equal to y squared plus 3, can y be represented as a mathematical function of x? So the way they've written it, x is being represented as a mathematical function of y. We could even say that x as a function of y is equal to y squared plus 3. Now let's see if we can do it the other way around, if we can represent y as a function of x. So one way you could think about it is you could essentially try to solve for y here. So let's do that. So I have x is equal to y squared plus 3. Subtract 3 from both sides. You get x minus 3 is equal to y squared. Now the next step is going to be tricky. X minus 3 is equal to y squared. So y could be equal to, and I'm just going to swap the sides, y could be equal to, if we take the square root of both sides, it could be the positive square root of x minus 3, or it could be the negative square root, or y could be the negative square root of x minus 3. If you don't believe me, square both sides of this. You'll get y squared is equal to x minus 3. Square both sides of this. You're going to get y squared is equal to, well, the negative squared is just going to be a positive 1, and you're going to get y squared is equal to x minus 3. So this is a situation here where for a given x, you could actually have two y values. Let me show you. So let's say, let me attempt to sketch this graph. So let's say this is our y-axis. Let's sketch, I guess I could call it this relation. This is our x-axis. And this right over here, y is a positive square root of x minus 3. That's going to look like this. So if this is x is equal to 3, it's going to look like this. That's y is equal to the positive square root of x minus 3. And this over here, y is equal to the negative square root of x minus 3, is going to look something like this. It's going to look something... It should make it a little bit more symmetric looking because it's going to essentially be the mirror image if you flip over the x-axis. So it's going to look something like this. Y is equal to the negative square root of x minus 3. And this right over here, this relationship cannot be, this right over here is not a function of x. For a given x, in order to be a function of x, for a given x, it has to map to exactly one value for the function. But here you see it's mapping to two values of the function. So for example, let's say we take x is equal to 4. So x equals 4 could get us to y is equal to 1. 4 minus 3 is 1. Take the positive square root. It could be 1. Or you could have x equals 4 and y is equal to negative 1. So you can't have the situation, if you were to make a table, x and y as a function of x. You can't have x is equal to 4, and at one point it equals 1. And then in another interpretation of it, when x is equal to 4, you get to negative 1. You can't have one input mapping to two outputs and still be a function. So in this case, the relation cannot... For this relation, y cannot be represented as a mathematical function of x.